Okay, so today is one of those lessons where we just kind of go over some vocabulary of things and just recognizing where numbers go. So hopefully you've done this before. This should again just be a review of things from Algebra 1, but there are things that are so important to Algebra 2 that we have to make sure we recover them. We're going to talk about polynomials. The term polynomial means many terms. Poly just means many. So if we've got one term, we would call it a monomial. If we've got two terms, we'd call it a binomial. 3 is a trinomial. And if we've got 4 or more terms, we're just going to call all of those polynomials. We're not going to name every single one above it. So we're going to talk about different kind of polynomials. All of these are things that we're going to refer to in here. Now, when we're talking about polynomials, we're talking about terms, and we'll address what a term is here in a minute, that are separated by plus or minus signs. So the biggest thing is that they're separated by plus or minus. So you'll see in some of the examples here that there are going to be terms that, like, when we're going to see a whole bunch of things. We're going to see letters. We are going to see different things. But what we're looking at here are things that are separated by pluses and minuses. Now, we've got things that are polynomials and things that are not. So, for example, here, when we deal with polynomials, we're dealing with things that are being added, subtracted, multiplied, but not things that are being divided. So we're not really interested in things that are being divided. So if you notice in each of these cases and examples of polynomials, like 3x to the 4th power, that is just two things being multiplied together. There's 3 and there's x to the 4th power. On the next one, we have got two terms. And the way that I know that there's two terms is what I usually do is this. If I'm unsure, I circle the pluses and minuses, and then I'll just underline everything else. And I go, okay, I have two terms there. So this is two terms. This would be a binomial. One of the terms is 2z to the 12th power, and the other term is 9z to the 3rd power. Here I've got one term, because notice nothing is being separated by pluses or minuses. Here's one term. These are monomials. And then finally, I've got a binomial because they're separated by a plus or minus. It doesn't mean that there's two things stuck together like multiplication. So one thing that has to be true for polynomials is that they're allowed to have exponents. But those exponents, there's a couple things that need to be true about them. They need to be numbers, but not only just numbers, they need to be positive integers. So we're talking about whole numbers that are positive. So not -1, not 1/2. Those things would not count. And so if you'll see, a lot of those here, the difference between the top and the bottom is in one case, we've got more than just an integer there. We don't have a number. It's a variable. That means that lots of things could go in there. So this one would not be a polynomial because it doesn't have a number as its exponent. Well, here I see two terms. However, there's more than just adding, subtracting, and multiplying going on. There's the absolute value, which is a whole different thing there going on. In this case, we have division going on. In this case, when we take the square root of a number, that's not an exponent that we can use, because you may or may not have learned this in Algebra 1, but that's the same thing as having a 1/2 exponent. So really everything where we're going at here is that everything in the top row is what we're going to be looking at and analyzing today. So we're going to look at the degree of a monomial and the degree of a polynomial. So this is degree of a polynomial. Okay, I opened the right one. Yes, ma'am.
Are you allowed to, if they give you, the square root, like that one?
Like this one?
Yeah, and they have, a number that would be 1 or 2 or 3. Does that count?
When you say 1 or 2 or 3, where would that 1 or 2 or 3 go?
In place of 1/2, so it would be the whole number?
Well, then it wouldn't be a square root. What I mean is that these two things are mathematically equivalent. And again, some people have learned this, some people have not. These two things mean exactly the same thing. When I see x to the 1/2 power, that means the square root of x. If I say 9 to the 1/2 power, that means exactly the same thing as this.
Okay.
So this, everybody kind of understands, they could probably do that, but this one stumps them. But really, they're the exact same thing. All right, so we're going to talk about the degree of a polynomial or the degree of a monomial. So remember that a monomial is just one term. For example, here is one term, here is one term, here is one term. Those would all be monomials. Well, when we're talking about monomials, it just means the sum of the exponents of the variable. So here, I've just got one thing, and I'm going to add up all of the exponents. So if I were to add up all of the exponents here, what number would I get? I'm not trying to trick you. It's easier than it sounds.
4.
It's just 4. Because 3 is not an exponent. So real quick, just in case you needed a refresher, these numbers in front here are called coefficients. They go in front. But the exponents, that's these numbers that like we're raising something to that power. So I'm talking about those when we're talking about degrees. We're going to be looking at those a lot. Now, this only applies to monomials. There's something different for monomials and our other polynomials when there's many terms. Like for here, what would I say is the degree of this monomial? 7. It's just 7. All I see is there's one variable and the exponent on it is 7. Here, I've got, what is the degree of that one? 101. Now I'm going to try to trick you here. Yes, so hope you're already going to beat me to where I'm trying to trick you. This is a monomial. That's only one term. It's not being separated by more than one thing. What is the degree of this monomial? 6, because we need to add them together. Let me try to get you one more time. 3. Even though you don't see a 1 there, we know that that 1 is implied on the x, that this is really a 1 right there. So this degree would be 3, and this degree would be 6.
So if there's nothing on the x, there's always like it's a 1.
Correct. It's always like a 1. It's like if I always write this, if I just write x, you understand that that is 1x, right? Mm-hmm. It's the same kind of situation, except for we're talking about exponents now. Okay, so that's for monomials, but the degree of a polynomial, like these right here, well, you do not just add those together. When there's more than one thing, you do not just add them together. What we're going to do for our polynomials, we're going to use the greatest exponent when written in standard form. So we're going to look at each one of these individually. We're going to look at this one, and we're going to look at this one individually. Like this one has a degree of 12. This one has a degree of 3. Which one of those is greater? 12. So the degree of that binomial would be 12. When I look at another one, do I have another one here? So what would the degree of this binomial be? 3. So there's one situation where we add them, and then there's another situation where we just take the highest number that we see. So the way that we tell the difference is, remember that polynomials are separated by those pluses or minus. Now, what we were talking about, and I think, Gabby, you were just asking me a second ago, is about that number in front, that leading coefficient. So we're going to talk about things written in standard form, and I'm going to say that a lot. So just to clear that up, what I mean is when things are in standard form, it means that the highest exponent is first, followed by the next highest exponent, followed by the next highest exponent, followed by the next highest exponent. So if you notice here, this one has a 3, this one has a 2, this one has a 1, and this has a 0 exponent. If you don't believe me that is x to the 0 power, what is 1 to the 0 power? 1. Remember, anything raised to the 0 power will be 1, except for 0 to the 0 power does not equal 1. That's the only one that's different. 2 to the 0 power equals 1. In this case, x to the 0 power equals 1. So really, right there, that's a 0 power. So we're just writing them in decreasing order there. So when we rewrite these in standard form, and you are going to be asked to write things in standard form, that just means put the highest degree first, followed by the next highest, followed by the next highest, followed by the next highest. If you're missing one, that's okay. Just put them in order. The tallest kid goes first, then the next tallest, then the next tallest. You know what I mean? It's got to go in decreasing order. There are 1, 2, 3, 4 terms here. That's 1, 2, 3. There's 4 terms. This is a polynomial. And the degree of this polynomial is the highest one that I see there. And the highest one that I see would be 3. So this one has a degree of 3. Yes, ma'am?
So if you don't have the x there, like on 17, if you have to fill in a variable, do you just automatically put 0 above it?
You won't have to. I just like to talk about that because it's important to understand that, like, when we start doing things later, I'm going to be talking about x to the 0 power, and I just want you to get used to that it's actually there. It's there. There's always, I mean, if I wanted to talk about any number, I can put, if I said the number 7 has an x attached to it, you'd be like, no, it doesn't. I'd be like, sure, because look, x to the 0 power. And you'd be like, what? And I would go, well, x to the 0 power is just 1, and 7 times 1 is 7. That's really what we're going to do with this in the future. So just where you can see where we're going. Yes, ma'am?
So the leading coefficient will be 5, 8, and 3?
Right, so the leading coefficient is the number that is in the very front. And that's why it says line leader there. It's like the number that is at the very beginning. Notice that they are in descending order. And the leading coefficient, it's the one that's leading this line, is 5. The leading coefficient is 5. The degree of the polynomial is 3. So there's two separate things that we're asking for. The leading coefficient is the number that's out in front when we have them in descending order. The degree of a polynomial is the highest power you see of all the terms. There are 4 terms there. That term has a degree of 3.
Would you add them all, like all the...
You would only add them if you only have one term. Now, let me show you. Here's an example. Let me show you an example here down below. There's an example where we're going to add them in just a moment. Let's talk about this. Now, here's the one thing. It says state the degree and leading coefficient here. But this is very misleading on this problem. There's something here that kind of is a lie, because before we can start rearranging these in order, something's going to go wrong when we try to put these in order. Let's put them in order. So let's put the highest power first, the one that has the highest degree first. What do you mean solve it? Well, because I don't know what it equals. There's no equal sign there. But there's something that actually, from the very first step, you should be like, wait, but why this? What do I do in this situation? Yes, sir. He's saying combine like terms. Why did you say combine like terms? What could be combined up there? Notice that these can be combined from the very beginning. If there's something to be combined, we're going to do it. What? No, you're... Yeah, no, we're going to do that too. That's another thing. So what does this get combined with?
4.
The 4x. Is there anything else that can be combined? The 8 and the negative 2. So let's do all those things. Let's start with that red ones, because we saw those first. Negative 3x squared plus x squared. What does that give me? Good. Negative 2x squared. Now, here's why we need to do this. Because can you see now that the number that's going to be out front is actually negative 2 and not negative 3? Like, it's not going to be this number. It's not going to be that number. The number that's going to be way out in front is negative 2, which was never even there in the beginning. We couldn't see it. Let's deal with the blue numbers now. X plus 4x. How much? 5x. And then finally, 8 minus 2. 6. So what we've got here is a polynomial that is written in standard form. Once you write it in standard form, the hardest part is done. So let's talk about now what is the degree. Let me switch to black just so I'm not color coding this. Degree of this polynomial. 2, because that is the highest exponent I see up there. The degree is 2. Now, the leading coefficient, I'm just going to use LC for leading coefficient, is what? Negative 2. Now, if you're not taking these down in your notes, you're going to want to take a moment and make sure you get those copied down, because this is what you are doing in your homework. So I'm going to pause for a second so people can get caught up, because I see some people aren't writing yet. I'm going to show you on the next one. We're actually going to do another, on the B one right there, we're going to do another one. But in this case, the leading coefficient is the number that is in the very front. It's in the very front of the line. It's the one attached in front of the x squared there.
It doesn't matter what order.
Well, I had to write it in standard form first. So here's where I wrote it in standard form. It has to be in standard form. And from there, here's where I got the numbers. Negative 2 was my leading coefficient. It came from right there. And this 2, the degree, came from because that was the biggest exponent I saw out there, a 2. Yes, ma'am?
Do you solve this the same way if you have binomials or?
We're not actually even solving them. All we're doing is stating the degree and the leading coefficient.
But like for binomials and trinomials, it's not a monomial or a polynomial. Is that considered, are those considered polynomials?
Is this a polynomial? Is that what you're saying?
No, like if you have 2 terms or 3 terms.
Right,
is it a
so
polynomial?
the only one that we're going to do where we add them, and actually we're going to see it on B here. So I think I'm going to answer your question on B. So if you'll hold it for 1 second, and if I don't answer your question on B, then let's go back to it. Because B is a little bit different here. There's a lot going on here. So remember in the last one, we needed to see whether there's anything that can be combined here. And this one takes a minute. So if you notice anything that you can combine, just let me know. Yes, ma'am?
X3 and x to the third power and y to the third power minus x to the third power is 1.
Okay, so let's do that right away. Those can definitely be combined because the reason we can combine them is because x has the same power and y has the same power. These are exactly the same kind of things. So what do I get when I have x to the third power, y to the third power, minus x to the third power, y to the third power?
0. Couldn't you just combine the exponents?
Don't they cancel out?
Well, hold on. We got a couple things. What was your question first?
Can't you just add the x3, y3?
No, we don't add those together because they're separate things. If they were both x's, then we'll talk about what you're going to do there. So right there, x to the third power, y to the third power, minus x to the third power, y to the third power is going to equal what? 0. Because when you have anything take away that same something, if I have 20 minus 20, it's 0. Anything minus itself is going to be 0. So guess what? That's gone. We can disregard it. It's not even there. So what else? Is there anything else we can do?
Yeah, 6xy
This one, negative 6xy, the fourth.
plus 3xy.
Notice that the x's have the same power and the y's have the same power. So here's what we've got. Negative 6xy to the fourth power plus 3xy to the fourth power. What does that give me? Negative 3 x
Keep the
y. Yep. Because it's like I have negative 6 apples and 3 apples. It's negative 6 of something and 3 of something. Those somethings are the same something. So what we end up is with negative 3xy to the fourth power. There's our first thing right there. Okay, so anything else that we can combine? No. So you cannot combine those last 2 terms because this x and this x do not match. So all I'm going to do is rewrite those. Plus 2x to the third power, y, minus 4x to the second power, y. Now, we're going to look for the degree, and we're going to look for the leading coefficient. I'll tell you the leading coefficient is super easy. The degree takes a little bit of thought on this. So what is the leading coefficient?
4.
It's the one that's in the front of this line. So like we wrote, it's what? Negative 3. It's negative 3 because it's the one that's right out front. I wrote it in standard form. It's right out front. The biggest power is there. So the question is, now this is a polynomial, and I'm telling you right now that it takes a little more thought, which must mean it's not perfectly obvious. It doesn't mean that you couldn't get it very quickly. It just means it might take a little more thought. What is the degree of this polynomial?
5.
Bro, how'd you get 5?
Add 4 and 1.
Okay, so remember that if I want to know, we know that this one looks like it's the biggest there, and I want to know, well, what is the degree of this? It's got a 4, but it also has a 1. So just for that one individual thing, what is its degree? That's 5. What is the degree of this one right here?
4.
That's 4. So we got a 5, a 4, and what's the degree of this one here?
3.
So do we agree that 5 is the biggest number here? Okay, so the degree of this polynomial is 5. That's the one that takes a little bit more work there because 4 is your first impulse. I see a 4 there. 4 is the biggest number. It must be 4. Well, sometimes you have to check them and go, oh, okay, I see that has a degree of 5. Therefore, like it's a 1 and a 4 there, it is the highest degree. Did that answer your question from earlier about the monomials? You were asking me about
Yeah,
monomials.
it's just because the wording when it says like the degree of a monomial or the degree of a polynomial, what is a binomial and trinomial?
Okay, so all of these, like these polynomials just mean something with many terms. So like we'll refer to these in general as polynomials. There's lots of different things. Like there's ones with 3, with 2, whatever. But really when we're talking about only one term, like just this is just one term, there's nothing really to add together. There's only one variable, nothing to add together. So when I look for the highest degree of this, I'm only looking at that. There's nothing else to look at. And I go, well, all I see is there's a 7. Well, but when I look at many things together, like there's many things, there are 4 different things there. When I look at many of them, I need to look at which is the highest one. That's what I'm looking for.
If you have 2 terms.
If I have 2 terms, I'm still looking for them. So let me give you an example of 2 terms. Let's say I've got 3x squared y squared plus 4x y squared. So right there, I'm saying here's a polynomial. There's more than one thing. There are 2 things here. If I said, what is the degree of this polynomial, what would you tell me?
4.
Okay, good, 4, because notice here, 2 and 2 is 4, and this one is 1 and 2, which is 3. So the highest degree here is 4. Yes, ma'am?
That thing you said you couldn't add them. 'Cause they're different.
Oh, no, but I thought you meant like combine. Well, we were talking about combining like terms, and you were saying add them together.
I thought, sorry.
So maybe I misunderstood what you were saying, because we were talking about combining like terms, and you were saying add them together, so I maybe misunderstood what you were saying. So the way that we find the degree is definitely to add them together. So I'm sorry if I misunderstood what you were saying there. We definitely, to find the degree, we're going to add the exponents together. We cannot combine like terms like that, which is something different. All right, so let's try. Here's a couple more things that we need to know. We are going to classify. The word classify just means name. When you're classifying animals, you're just naming them, giving them names. Like you are classifying something as a... When we're classifying something, we're just naming it. That's all it means. Whether you're doing it in math class or in science class, you're naming something. So we're going to name these by their degree, meaning we're going to look at the highest degree and then name it. And here's what you need to know. You are going to be responsible for knowing all of these terms based on their degree. Here's what I mean. Notice over here, I just have a -9. And I told you a minute ago that this is just like 9. It's got a 0 right there, right? That's a 0. There are 0 x's there, if you will. Its degree is 0. We would call this a constant. Like that's just a constant. It's just a number right there. Whereas x in this next case right here, x only has x to the first power. So since the degree is only a 1, we call that a linear polynomial. Then we get on to what is the highest degree of this line right here? What's the highest degree? 2. So its degree is 2, and we call that quadratic. Now you might have heard that before because that is what parabolas are. That like U-type shape that you've seen before, that's where it comes from. What is the degree of this one right here? 3, and what we call that is a cubic polynomial because it has the degree of 3. It is a third power, if you will. Notice here on this one, what degree is that? 4. Now, just like there are 4 quarters in a dollar, this is called quartic. Or like 4 quarts to a gallon, this is quartic. And this last one here, the highest power is 5. We call something that is of degree 5 quintic. Now, I'm telling you right now, super important, you need to know these. If that means make note cards, if that means that you got to make a Quizlet, whatever it is, then that's going to help you out there. But we're going to test this right now. We are going to look at a polynomial, and we're going to classify the following. We're going to name the following. We're going to decide what the leading coefficient is, the degree, how many terms, and its name. So remember, if there is, this should be in your notes. It should be the same thing you guys have in your notes there. But if you have one term, we call that a monomial. If we have two terms, we call it a binomial. 3 is a trinomial. 4 or more is a polynomial. So we're going to do a couple things here. First of all, we should rewrite this in standard form. Somebody tell me what to write. 4x cubed, that's the highest power. Plus 2x, that's the next highest power. Minus 1. Now we have it in standard form. Now we can answer those questions. So what is the leading coefficient? 4. It's the number that is out front. Now we're going to name the degree. This is a polynomial, so we're looking for the highest number. What is the degree of this polynomial? 3. We're going to talk about the number of terms. How many terms do I have there? 3. If you notice and you're not sure why it's 3, circle your pluses and your minuses, and you've got 1, 2, 3. It's the things being separated by the pluses or minuses. There are 3 terms. So this is going to be called a trinomial because there are 3 terms. I'm just going to write right next there as a note, this is a trinomial because there are 3 terms. And then finally, we're going to use the degree and the terms to give it a name. So if I named it by its degrees, what would we call it? Okay, good. So notice here, cubic. So the first word we want is cubic. And the second one comes from the terms. We have 3 terms. We call that a trinomial. This is a cubic trinomial. We're going to do these exact same steps every time. If you can tell me the leading coefficient, the degree, and the terms, you can get everything from that. I'll tell you, in my opinion, the hardest part is memorizing that chart. If you don't know that chart, well, that's a little bit harder then. So again, let's rewrite in standard form. If you don't write it in standard form, you'll get the wrong answers for leading coefficients. Tell me what to write first. Beautiful. Negative 2x squared. Next. Plus 4x. Plus 2. Now we have it in standard form. Now let's go through and write the leading coefficient, which is negative 2. That's that number out in the beginning. Now the degree. Notice again, the highest power there is 2, so is a degree of 2. How many terms do I have? Again, we have 3 terms. And if you can't see them, remember, circle your pluses and minuses, and 1, 2, 3 things being separated by them. What do we call something with 3 terms? The degree, and so something with 3 terms. Remember, it's a something nomial. What kind of nomial is it? A trinomial, and it is a trinomial. And something with a degree of 2 is called? Quadratic. So this is a quadratic trinomial. Can I tell you where most people make a mistake? They last minute cram this chart. They wait till the last minute to try to learn this chart, and then they have to take a quiz or a test on it. And here's what happens. You know the word is something like quad, and you write like quadrilateral trinomial. I don't give you credit for that. So please understand that getting close to the word is like you jumped off the high dive and you landed close to the pool. That's what I mean. Getting close sometimes doesn't count. You know what I mean? It's real disasters. So this is one of those cases that's very important that we get the right words. All right, let's write in standard form. Somebody hook me up. I'm going to shut up for once. Beautiful. 7x to the third plus x squared. Okay. Will you keep going for me? We need a leading coefficient. It's the number that's out front. We need a degree. The degree is 3. That comes from the highest exponent I see. The amount of terms. 4 terms. What do we call something with 4 terms? So this is going to be something nomial. When we say term... Well, no. So this is something nomial. Okay, so let me go back. So this is... Good, it's a polynomial. So polynomial. And you guys said that 3, the degree of 3 is what? Go back up here. If the degree is 3, what is its name? Right here, cubic.
You have 2 colons. Like 2 rows, 2 colons.
So, I'm sorry, cubic. I lost my train of thought there. Oh, I'm on the wrong one. Here we go. Cubic. Good. So now when we name it, it's just cubic polynomial. All right, Felissa, so here's something that I do in every single class that I've kind of waited to introduce into here, and those of you who have had me before know it's something I call throwing each other under the bus. Matthew, you've been with me before. What does it I mean, actually both of you have been here for throwing under the bus. What does it mean when I say that I'm going to allow you guys to start throwing each other under the bus in here?
Okay, so when you throw someone under the bus, so I'm going to answer this question as you see. So I answer the question. When you throw someone under the bus, essentially I'll pick a random person in the room, and they have to answer the next question.
You are forced to answer. So the great news is that if you answer a question, so like Felissa's got all the power right now. She gets to throw anybody she wants under the bus, and that person is going to be the person who answers my next question. There's no backing out of this one. She's already done her job. So what a lot of people like to do is to volunteer when they know the answer to a question. They're like, oh, I'll do it because I don't want to be thrown under the bus later. I'd rather be throwing people under the bus than being thrown under the bus. So the great thing is I introduced this right now because I thought it was a perfect time. These aren't like horrible problems. It's a comfortable area where we can go, who cares if we make mistakes? So they don't even need to volunteer. You get to pick whoever you want. It doesn't matter whether their hands are up or not. You can pick somebody who wants to, or you can make a new friend. You can be like, I'm sorry, I don't know your name, but I would like you to answer this question.
Yeah, didn't.
So not friendly.
Well, here's the thing. Be assured of this. I am forcing her to do this. So if she calls on somebody, it's not her fault. Here, Felissa, you want me to make it easier for you? If you don't pick somebody, I pick you again. And I keep picking you over and over again for every single question until you pick somebody else. It's my encouragement. So really, it's not her fault. You can blame it all on me. It's all on me. I'm going to force her to do it. Sure. The good news, though, is now you have the power after this. Is you get to throw somebody under the bus. X to the third power.
Minus 18x to the second power plus 3x minus 5.
Beautiful.
And then the end coefficient is 1.
You are my hero. There's a 1 out front whether you see it or not. It's not a 0. That is 1x cubed.
The degree is 3.
The degree is 3. And let's just make a note. What do we call something with a degree of 3?
Cubic.
That's cubic.
And then there's 4 terms.
Okay, so the amount of terms are 1, 2, 3, 4. That's 4 terms. What do we call something with 4 terms? A polynomial. Remember, the terms are going to be the nomial ones. So my final answer will just be cubic polynomial. So even though you don't see a 1 out in front of the x cubed, there's definitely a 1 there. So don't give me the letter. I don't want the letter. I want the number that's out in front of the letter. And even if you're like, wait a minute, but there's no number, you know that there's a 1 hidden there at all times. All right, so now we're going to talk about adding or subtracting polynomials, and which is really nice actually because when we're adding them, it's not a big deal because we're just going to add everything together. We're going to go 3x squared plus 7 plus x, and then we're going to add each of these things here. So plus 14x squared plus 2 plus x minus x. All I did was write it exactly as it was shown there. Now we do need to simplify this and we do need to write it in standard form. So what I'm going to do is I'm going to look at my highest powers first. So Sabrina, who's our victim? You know what's the worst thing about this is that some of you already know you're next. Do you know what I mean? It's like some people, like if you're friends with Joe, it either means you're completely safe or you're not completely safe. One of the two. All right, Joe, talk to me about this because I need to combine some of these things. What do you want to combine here?
3x and 14x squared.
Okay, and that becomes?
17x squared.
17x squared. Those are dealt with. What do you want to do next?
7 and 2.
Okay, 7 and 2.
9.
That becomes 9.
Those x's cancel on the right, and you get plus x.
Okay, these are gone because they cancel each other out at positive x and a negative x, and he says there's one x left there, so just plus x. So 17x squared plus x plus 9. Is this written in standard form?
Yes.
Yes, it is decreasing in powers. So now let's go through. It says write all answers. We just need to add or subtract. They didn't ask me to name the degree or anything like that. I didn't need to here. Did I do something wrong? I see a lot.
And you forgot an x squared, it's x squared, x squared,
Where did I forget the x squared?
on the second one. Plus 2 plus x squared minus x.
Oh, this was an x squared. I'm so sorry, Joe. I messed it up. That's all me, so that's not on him. I'm going to go back here. Let's just do a little correction. I'm going to erase this line. I wrote it incorrectly, and he went with my accident there, which was my fault. So I'm sorry, Joe. I'm going to make you go back and do it once more just so that we get it right, but I'll take the blame for that. That wasn't you. That was me. So we've got 3x squared. I'll try not to be adult this time and get it correct. 14x squared plus 2 plus x squared minus x. All right, give it to me one more time.
Okay, so 7 x squared plus 18x squared.
Okay, so that becomes 18x squared.
And then the x's cancel out, it'll be plus 9.
And then all I've got left is plus 9. Now notice that this said add or subtract, combine like terms, write all answers in standard form. Now please don't try to get this one into x equals something. Why do I know that this is not a problem where I'm going to do x equals something? What is it that's like missing to do x equals something? Matthew? There's no equal sign. So I'm not going to know what x equals because there is no equal sign, and I don't just get to create one. That is not something I'm allowed to do in math. If there was an equal sign, I could start solving it. This is where I stop. There's no more terms to be combined. Joe, who do you want to throw under the bus?
Yeah,
Knew it.
All right, so let me just rewrite this. This is negative 3x squared plus 6x. Since we're only adding these things, all I need to do is just rewrite plus 6x squared plus 16x to the third minus 5. Talk to me.
Okay, so first you're gonna put the 16x cubed.
Okay, so we've got 16x cubed. That's nothing. There's nothing for it to be combined with. 16x cubed. That's done with.
And then I'm gonna combine negative 3x squared with 6x squared.
Okay.
It's gonna be negative, or no, just 3x squared.
A positive 3x squared.
And then I'm gonna combine, I'm just gonna write down 6x.
Good. 6x doesn't have anybody to combine with.
And subtract 5 from 11 and negative 16.
Beautiful. That's all we're doing here. Now, it's going to become a little bit different when we do subtraction. Because when you add two numbers, you just combine them. But when you subtract them, something different happens. So now, we're going to do the same thing, but with subtraction. But what this means is you're going to take 1 minus x and subtract each of these things. Subtraction is different. So I'm going to subtract 3x squared, and I'm going to subtract 2x, and I'm going to subtract negative 5. Are we okay with what I just did there? Okay, because what I did, if you're not following, is I took this negative and I applied it to each of these things, and that's where all of these numbers came from, right there. But there's some things that can be simplified. And Gabby, who's going to simplify them for us? Because we are subtracting a negative number. So I had to write two negatives there. I can't disregard that. I can't just pretend it didn't happen.
So could you just say you're distributing the sign that's in the
Yes, that's exactly what I did. I distributed that negative to each of them. I subtracted 3x squared, I subtracted 2x, and I subtracted negative 5. It went to each of them. Gabby, who's up?
Andres.
All right. I love the looks that follow. That's the best part. So, talk to me about what you want to do.
So you gotta combine.
Okay?
So we have two x's, so negative x and negative 2x.
Negative x and negative
So
2x.
we're putting in standard form, so negative 3x squared would go first.
Okay, so we'll write this first. Negative 3x squared.
And then that would turn into a negative 3x.
Negative 3x.
And then you have 1
Okay, 1 minus a negative 5. Remember, these two negatives become positive, which is the same thing as 1 plus 5, which becomes 6. So wait, 1 minus, look, so 1 minus negative 5. If you are subtracting a negative number, one of the things that we talked about, that this is the same thing as adding the opposite. So a lot of you learned this as when you see two negatives next to each other, it's plus plus. That's what you learned. Like, I know a lot of teachers do that. But if you want to, it's the same thing as adding the opposite. So what we've got there is that those two negatives next to each other are going to become...
Multiply like a negative 1 to the 5 because it's distributed.
No, we've got 1 minus... Let me just go back. I just put those parentheses around it so you can see it. That's 1 minus negative 5. 1 minus negative 5. And notice I just put those two lines.
No, like when you're distributing, like I got plus 5.
Here? Yeah, so you ended up as the same thing. A negative times a negative is a plus 5. You just distributed right there. It's the same thing. We're all in the same boat. You just did it in a different order.
So why'd you write negative, negative? Why didn't you just change it to a plus?
Because some people will get that and some people will be like, wait, what I'm saying is that you're subtracting each of those things. Minus 3x squared, minus 2x, minus negative 5, but it's the same thing as distributing the negative. Either way, they both work out the same way. But we all agree that we end up at 6, right? Okay. And then we'll stop after this one. Andres, who are you throwing under the bus? Which one? We have 2 now. Did you guys all meet Melanie? Are you like transfer student or just transferred into here? Okay. I just didn't know like whether you were... Yeah? All right, so just remember that I have to... Now, if you want, you can distribute this, or you can say that we are subtracting each of these. It's the same thing. So let's do distributing this time. Minus 15x squared. Minus 3x. And a negative times a negative 2 is a positive 2. It ends up the same either way. But notice that negative needs to go with each of those numbers, which doesn't have to happen with plus. Plus doesn't change things to the opposite. Negative does. Melanie, Dime.
Yes.
Talk to me.
Alright, so you're gonna grab the negative, actually, you have positive 2, and add that to positive 12, so you're 14. Alright, and then you can grab 6x squared and negative 15x squared, and that gives you a negative 9x squared.
Negative 9x squared.
And 5x3, you just leave it, and negative 3x, you just leave it.
Why am I not okay with her answer right now?
Because it's arranged.
Ah, so we need it in standard form. So just rearrange it for me.
Alright, so you're gonna put a 5x cube right there, and then it's negative 9x squared, and it's negative 3x, and positive 3.
Beautiful. That's what I'm looking for. So if you got it here and didn't put it in standard form, you'd get some points, but not all the points. So we'll stop there. By the way, if there are any problems in the homework that talk about the zeros and looking at graphs, don't worry about those. We'll talk about those tomorrow. Don't stress them if they're on the homework. I just don't know. I was hoping we'd get through a little more, but it's okay. I would rather we know this well than try to jam everything in. I'd rather we feel comfortable with the material we have than try to just force more material in.